All right, today we're going to dive way deeper than the familiar A, B, and O to uncover a hidden world right there inside your own bloodstream. We're going to explore these incredibly complex blood systems that are not only critical in modern medicine, but also tell these amazing stories about human history and survival. Go on, I bet you can name it instantly. A positive, O negative, B negative, right? We learn it, we might even carry it on a card. We feel like we know it. But what if I told you that simple letter and that plus or minus sign are just the beginning? You know, the ABO and RH systems are famous for sure, but there are only two of dozens of blood group systems coding your red blood cells. So today we're exploring three of the most important other systems: Kell, Duffy, and Kidd. And trust me, each one has a fascinating story and a life or death role in medicine. First up, we've got the Kell system. You can think of this one as the next most important system to know right after the big ones we're all familiar with. It is a major, major player in transfusion medicine, and getting a mismatch here can be really serious. So the Kell system has two major kind of opposing antigens, a big K and a little k. And this is where it gets super interesting. There's this incredible imbalance. The big K antigen is actually pretty rare, found in just under 9% of people. Meanwhile, its partner, the little k antigen, is nearly universal. Over 90% of us have it. And this huge difference is exactly why it's so critical to get right in transfusions. So just how powerful is this rare K antigen? Well, when it comes to provoking an immune response, it's number 2. Yep, it's second only to the D antigen, that's the positive or negative in your Rh blood type. What that means is it's highly immunogenic. Your body is very likely to see it as a foreign invader and build antibodies to attack it. And if your body does create those antibodies, well, the consequences are severe. We're not talking about minor antibodies here. These are a really powerful memory-forming type called IgG. If you're exposed through a transfusion or even during a pregnancy, your body can start producing them, leading to these severe reactions where the body literally attacks the new blood, or it can even cause a dangerous condition for a developing baby. And believe it or not, the Kell system's importance goes even deeper than transfusions. Take a look at these strange, spiky-looking red blood cells. These are from someone with a rare condition called the McLeod phenotype, and it's all caused by a missing protein that's structurally related to the Kell system. This is just a perfect illustration of how one tiny change on a blood cell can have these massive system-wide effects. McLeod syndrome isn't just about weirdly shaped cells. It leads to severe muscular and neurological problems, and it's also linked to a disorder where the immune system can't properly fight off infections. It just goes to show you these antigens aren't just labels. They are vital pieces of our cellular machinery. Okay, so our next system, Duffy, is going to take us out of the hospital and way back into the deep history of human evolution and our long, long battle with one of our oldest enemies. Yeah, this is a story about malaria. For millennia, this tiny parasite has literally shaped human populations, and the evidence of that fight is written directly onto our red blood cells all through the Duffy blood group system. So how does this all work? Well, the malaria parasite needs a way into our red blood cells to survive and multiply, right? It turns out certain species of malaria use the Duffy antigens, Phi or Phi B, as their front door. They're like a docking port. If you don't have those antigens on your cells, the parasite can't get in. It's just locked out. And this is where you can literally see evolution in action. The Duffy negative phenotype, the one that locks out malaria, is extremely common in populations from West and Central Africa. These are areas where malaria has been a huge selective pressure for thousands of years. But in Caucasian populations, where that pressure was historically super low, the phenotype is really rare. It's a perfect textbook example of natural selection playing out right there in our blood. All right, our third system, Kidd, presents a totally different kind of challenge. This one isn't about raw power or some grand evolutionary history. No, this one is all about stealth. The Kidd system is a notorious, elusive little troublemaker in the blood bank. And the reason Kidd is so tricky is because of its connection to something called a delayed hemolytic transfusion reaction. Now, unlike an immediate, obvious reaction, this is more of a slow burn crisis, where a patient's body starts destroying the transfused blood days or sometimes even weeks after they've already gone home from the hospital. So, why does this happen? Well, KIT antibodies are famous in the lab for being weak and just really difficult to detect. Their levels can drop off over time, basically making them disappear, only to roar back to life after another transfusion. They also tend to hide alongside other antibodies, making them really easy to miss. And that's exactly why they're such a common culprit behind those dangerous delayed reactions.
Okay, so we've seen a powerful antigen, a wild story of survival, and an elusive antibody. So, what's the big picture? Why does knowing about these hidden systems matter so much?
It matters because your blood is a far more complex and unique tapestry than you might think. We've just touched on 3 systems, but there are so many more. Understanding this diversity is absolutely essential for safe blood transfusions and for preventing disease in newborns. And, like we saw with Duffy, it gives us this incredible window into our own evolutionary past. At the end of the day, digging into this complexity isn't just some academic exercise. It is the absolute foundation of safe, modern transfusion medicine. And as we move more and more towards personalized healthcare, knowing the intricate details of a person's blood far beyond just A, B, O, well, that's going to become even more important. It really makes you wonder, doesn't it? As we get better and better at reading this incredibly complex language written in our own veins, what other secrets about who we are, where we came from, and where we're going are just waiting there to be discovered?